And welcome back. As we go ahead and continue to dive into our discussion on packages, let's take a moment to discuss in depth package names and directories. So in order to have a discussion around this, we first need to discuss the class path variable. So recall in our previous lesson how we attempted to add a package into our program. A package name is not an arbitrary identifier. Instead, it is a form of a path name to the directory containing the classes that are in that package. So if we want to find the directory for a package, Java needs two things. It needs what is that name of the package you're looking to find, and the value of your class path variable. Now you should already be familiar with the environment variable of your operating system, which is known as a path variable. So this is like, for example, C:// and it goes on, users, blah, blah, blah. Now the class path variable is very similar to that environment variable used to help locate those Java packages. Now the value of your class path variable tells Java where to begin its search for a package. It's not a Java variable though. Instead, this is actually an environment variable that's actually part of your operating system. The value of the class path variable is really just a list of directories in your program. So the exact syntax for this list varies also from one operating system to another, but ultimately it should be the same syntax as used for an ordinary path variable. Now when Java is looking for a package, it begins to search in the directories that are listed in that class path variable. Now the name of a package specifies the relative path name for the directory that contains the package classes. It is a relative path name because it assumes that you start in one of the directories listed in your class path variable. For example, suppose the following is directly listed in that class path variable: libraries/new libraries. And suppose your package libraries are in the directory libraries/new libraries/utilities/numeric stuff. In this case, the package should be named utilities.numeric stuff, and all the classes in the file must start with the package statement package utilities.numeric stuff. The dot in the package name means essentially the same thing as the slash that's used by the operating system for directory paths. The package name tells you, and ultimately Java, what subdirectories to go through to find that package classes starting from a directory in the class path. Now, if there happen to be two directories in the class path variable that can be used, then all the ones that can be used, Java always uses whatever one is listed first in that class path variable. Any class that uses the class in this utilities.numeric stuff package must contain either the import statement, import utilities.numeric stuff.star, or the import statement for each class in the package that is used. The way you set the value of your class path variable depends on your operating system, but here's some suggestions that may or may not work. So the class path variable is usually spelled as all one word with uppercase, as in class path. You'll probably have a plain old path variable that tells the operating system where to find the code for the commands such as javac and other commands you can use as single line commands. If you can find out how to set the path variable, you should be able to set the class path variable in the same way. Now, if you're using a Windows machine, such as the one I'm on right now, you can use the class path variable by setting and creating an environment variable named class path using the control panel. Now, for what we're going to assume that class path directories are separated by a semicolon. This is a pretty common thing, actually, but some operating systems use other separators, such as a colon. Ultimately, depending on what operating system you're working in, check the documentation for the operating system to see if a semicolon does not work as a separator. Now, let's jump right into talking about packages. Now we got all this class path out of the way. It should give us enough for what we actually need to deep dive for this lesson, which is looking at package names. In this diagram, you can see how the different classes are nested in the different directories. So in here, of course, we have our programs. We have a library, we have old libraries and new libraries that are part of it. Inside of new libraries, we have input, output, and utilities. Inside of utilities, you can see we have string stuff and numeric stuff. And if I open up numeric stuff, you can see we have two classes. We have a class and another class. In this example here, both a class and another class are both in this numeric stuff directory. Remember, we sometimes use the term directory and folder very interchangeably, so that's why you'll see this as a folder icon. Now, there's a pitfall to keep in mind here is that subdirectories are not automatically imported. So let's say we have two packages, utilities numeric stuff and utilities numeric stuff.statistical. In this case, we know that utilities.numeric stuff.statistical is in a subdirectory or a subfolder of the directory folder containing utilities.numeric stuff. Now, this can lead to some programs to assume, well, the following import statement would import both packages. Import utilities.numericstuff.star. When you import an entire package, though, you're not going to import the entire subdirectory of packages. So if I wanted to import all classes in both packages, I would need both import utilities.numericstuff.star and import utilities.numericstuff.statistical. If you don't do that, you're only going to get the one package set. And of course, it doesn't do any good to talk about packages if we don't mention the default package. All the classes in our current directory that do not belong to some other package belong to an unnamed package called the default package. And we saw this when we looked at classes last time in our program. If the current directory is, of course, on our class path, all the classes in the default packages are automatically available to your code. And this is why we always assume that all the classes that we have defined are in that same directory. That way, we don't have to worry about cluttering our discussion with concern about whether or not we have the correct import statements and stuff like that. Now, as mentioned previously, we have been working with and will continue to use the default package. There might become a time when we do want to make and build our own packages because we want to have our own libraries. But for our learning purposes right now, working with the default package is perfectly acceptable. Now, another pitfall to keep in mind is not including the current directory in your class path. So, as we have discussed, the class path variable allows you to list more than one directory. Most operating systems will use a dot to indicate the current directory. Now, the current directory is not any one specific directory. It is the directory in which you are currently located. And if you don't know what that current directory is, then it's probably the directory that contains the class in which you're writing. So, if you're, for example, on a Windows machine, whatever folder has all those different files that we're currently building our project in, hey, that's your directory. So the following value for a class path variable lists two ordinary directories and the current directory. So for example, we have libraries/new libraries, semicolon, other stuff, /special Java. Now, whatever you set or change the class path variable, just make sure to include the current directory as one of the alternatives. With the above displayed class path value, if the package is not found by starting in either of the previous two directories, Java will look in the subdirectories of the current directory. If you want Java, of course, to check the current directory for the other directories on the class path variable, we need to make sure we list the current directory, which is the dot first, as follows. Library/new libraries/other stuff special Java. When looking for a package, Java tries the directories in the class path in order and uses the first one that works. Now, omitting the current directory from the class path variable can interfere with running Java programs, regardless of whether or not the programs use packages. If the current directory is omitted, then Java might not even be able to find the class file for the program itself, so you may not be able to run any programs at all. Thus, if you set the class path variable, it's critical that you include the current directory in that class path. Now, no such problems will occur if you have not set the class path variable at all. It arises only if you decide to set that class path variable. Now, if you're having problems setting the class path variable, one kind of workaround solution is to delete the class path variable completely and keep all the class files for one program in the same directory. This will allow you to still do some work while you seek advice on setting that class path variable. So, let's talk about specifying a class path variable when you compile. You can specify a class path variable when you're compiling a class. To do so, we add -classpath followed by the class path as illustrated in the following. Java C -classpath semicolon C :lib/numeric C /other stuff your class.java. When you run the class compiler as shown, you should again use the class path option as shown below. It's important that when we compile code that we include the current directory on the class path when we run that program. If your program's in the default package, it will not be found unless you include that current directory. So it's always best again to have including that current directory in all class paths. Now, because the class path specified in compiling and running your classes is input to a program, whether that's Java C or Java, that is part of the Java environment and not a command to the operating system. Therefore, you can use either the / or / in the class path, or which of these two your operating system actually uses. Now, this, of course, can lead to some potential name clashes. In addition to being a way of organizing libraries, packages also provide a way to deal with name clashes. A name clash is a situation in which two classes have the same name. In different programmers might be writing, for example, different packages, and they might inadvertently use the same name for a class. Now, that, of course, can lead to some ambiguity, which can be easily resolved by using the package name. Because then you say, let's say we have two classes that are both called my class, but you have a package called my package and another one called your package. Well, if you have my package of my class and your package of my class, those are technically going to differentiate which one of those you actually want to use. And let's talk lastly about some fully qualified class names. Suppose the package name Sally Pack contains a class named High Class, and another package named Joe's Pack contains a class named High Class. So this is kind of building off the example I just talked about. You can use both classes, actually named High Class, in the same program by using more complete names, such as Sally's Pack to High Class and Joe's Pack to High Class. So if I had a object, so if Sally's Pack to High Class, object 1 equals new Sally's Pack to High Class, and we do Joe's Pack to High Class, object 2 equals new Joe's Pack High Class. You'll notice that these names include the package name, such as Sally's Pack to High Class and Joe's Pack to High Class. These are what we call fully qualified class names. If you use fully qualified class names, you do not need to import the class, since this longer class name actually includes the package name. Now, the last thing I'm going to mention here is this is a lot of information for you to digest. And if you're still kind of feeling overwhelmed about all the ClassPath stuff and all these different things, don't stress over it. The important thing to note here, if you want to summarize and put everything as a big takeaway here, is understanding how we can use packages to really kind of make a library. And if we want to use those, we want to make sure we're pointing to the correct area. Now, some of the stuff is more important, for example, when you're going to execute code from the command line. Versus using something like Eclipse. In Eclipse, we don't have to worry about this as much, but this is still good stuff to know in case of, hey, I have some code. I need to execute it from the command line. What do I do? Now you have some of the information in front of you so that you'll have a better understanding of it, and you're a more well-rounded programmer.